In this lesson, we're going to be getting into what slope is and what slope means. And we're going to be starting this off with Mr. Slope Guy. And so you have this handout that was given to you. And if not, you can print it off the Google Classroom. But we'll be talking about him, and he is something that you're going to want to draw on your paper. And so just draw the eyebrows as slants, and then a plus sign, and then a negative. So its eyes is a plus sign here, a negative there. So this is positive slope. This is referred to as negative slope. And that we'll get into that a little later. And then we have the line going down with the nose, which is called undefined. So the U here, meaning undefined, meaning we can't define what the slope is exactly because it's a vertical line. And then the horizontal line going across. And these are referring to lines that you drew the other day, and you found where they had a solution or they intersected, and you had usually a positive and a negative slope, and they eventually touch and intersect at a point. And then occasionally on some of those problems that we did for you, they were parallel lines. They were either both positive or both negative and never touched. But horizontal lines have zero slope, and that's what the cheeks are for zero. So this is Mr. Slope Guy, and I'm going to go ahead and we're going to fill him out, and I'm going to show you where we're going to glue him in. And so we want to talk about what slope is. What exactly is slope? So slope, in the last lesson, you kind of learned about constant rate of change, which was your change in y over your change in x, and that's what we refer to as a constant rate of change, or slope of a line. Slope is also sometimes looked at as a unit rate, a comparison of rise over run. It might be miles per hour, and might be a unit rate where you're measuring miles on one axis, hours the other axis, and drawing a line, and that constant rate of change that you're traveling. And then you have slope, which could be called and these are all names for slope, constant of proportionality. And we'll be getting into a lot of these words that kind of all mean the same thing, just different ways of looking at numbers and values as they go along those lines. And then you have constant of variation. And we're giving you all of these language words because these are all words that you could possibly see on the STAR test or in your life and math, talking about it, and understanding that if they say, what is the constant rate of change, they're asking for slope. If they say, what is the unit rate, they're talking slope. If they want the constant of proportionality, they're talking about the slope of a line. The constant of variation, like how much does it vary, and that is the slope as well, as long as it's constant. So you see they're constant, meaning it grows at the same rate of change. And slope, a lot of the times, is written or informed as rise over run. It's how much y value rising that I have to my run value, which is along my x-axis. Okay, and so that's your rise over your run. And so we want to make sure that that's really understood, that rise is referring to the y value and x is referring to the run back and forth. And so that's why yesterday you learned that it's a constant rate of change of y, or you might remember this from yesterday, we did delta y over delta x, and that's referred to as slope, constant rate of change. I'm going to keep saying that word till it's in your brain. We are going to be gluing this down onto page 22, and I'm not going to glue it right now because I need to make copies of it. So I'm going to let you glue it, but it should be on page 22 here on the left-hand side. 21 should be on the other side from last time. And this is 3-2, and I just put notes up there. So we're going to switch gears over to this page. And this page is going to go in page 23, which is the page just opposite. But it is a full-size page. So just a reminder, those of you that have had me in the past, I always say to fold it, and I would recommend folding the page up to right below the word slope here, and then you'll glue it in sideways like that. So what is slope? Well, if you were listening to me really well, I said slope is the measure of what? It's the rate of change. It's the steepness. But I just didn't talk about that, how steep the line is. So is the measure of the, and I know this is a crazy word, but steep, like steep is how much of a slope does it have? The steepness of a line. Oh, it says of a line, so it's just steepness. Sorry about that. Not of. So it's just the steepness of a line. I'm looking for my whiteout. Sorry about that. Didn't read ahead. So slope is the measure of the steepness. How steep is that line? Is it a shallow line or is it a really steep one? If you're on a, I was gonna say roller skate and I lost my train of thought. Skateboard, sorry, a skateboard, and you're going on a line. If the line on the ramp looks like this, it's not very steep. But if the line's going like this, I don't think you're gonna wanna ride down it even with a bike. So it's the measure of the steepness, how steep the slope is. And this is, of course, the positive slope. And then going the other way is our negative slope. And so that's just kind of to help with your slope guide. It could have the same steepness, just one is a positive steepness on it and the other one's negative. So different ways to look at slope. And we just kind of talked about this, but you're going to see the letter M. And when you see the letter M, it's asking for the slope. M is slope. I know it's strange. I don't know why mathematicians chose M, but they did, and there it is, so get used to it. It is the amount of rise over run. It is the change in Y. I'm going to put the word change there because a lot of people don't know that that delta symbol there, that triangle, is change. So change in Y over the change in X. And again, you're going up and down first over the left and right movement. It's opposite of X before Y. And then to calculate it, if you have 2 points given, you plug it into this formula, and we're going to get into some examples. But again, it's the change in Y, so how much did it change is the subtraction of the 2, and then the changes in X is the subtraction of the 2 X's, and you get the change overall for the slope. So take a look at this triangle here. It looks like a ramp, right? Well, we have a rise of the ramp, and we have a run of the ramp. How far does it run? So the rise over here is 18, and the run is down here, which is 40. Therefore, I put 18 over 40. That's my rise over run, because remember, I put my Y over my X, and then I simply reduce it. And it reduces down to 9 over 20, which equals my slope, or M. So if I were on a piece of graph paper, what this is saying is I could plot a point right here, and as long as I rise 9 and run 20, I will have the same constant slope going up the line. And that's what slope is. And remember, it's rise over run. So if you look at this triangle, if I rise 9, it would be to here, and if I run 20, because I reduced it, it would be here, and it would be half the distance. But then if I went the full 18 and the full 40, I would be, and that's not quite half, I would be looking at the same relationship. Example 2. Sometimes you're just given a table. And on the table, you look for the change in Y between the Y's over the change in X. So in this situation, how much did the Y change from 4 to 6? And we would say that the distance from 4 to 6 is a positive 2 gain. It's getting bigger. The distance between 2 and 3 is a positive 1 gain. And so we're saying, what is the amount of change? How much did the points change? So the change in Y is 2, and the change in X value is 1. And in the world of fractions, we know that 2 over 1 is just 2. So we would say that the slope is 2, or you could say 2, or you can say 2 over 1, depending if you want your rise over run. And again, we know that 2 is 2 over 1, so saying the slope is 2 is fine, or it's 2 over 1. And here's an example 3. And in this example, you're given a graph, and it gives you 2 points. Well, again, what is the change in Y over the change in x. How far do you have to travel rise over run? With these kind of problems, I find it really easy to just put your pencil on the point and rise till you get to this distance here. So if you look at this, it looks just like a triangle like we had on example 1, except for it's turned upside down. So if you kind of see that triangle there, just turn upside down, or you could actually go this direction and make the triangle down here. And honestly, it doesn't matter. Just remember that you're going to rise and then run. So if I go from here to here, I'm going to rise 1, 2. So I'm going to rise 2. And then I'm going to run 1, 2, 3, 4. That's my x change. And so that'd be 2 over 4, which actually reduces down to 1 over 2. And I should have left room for that. So it's a half. Now you're probably saying, well, how do I know it's a half? Well, I didn't have to just go from blue dot to blue dot. I could have gone from this dot right here to the middle, and I kind of skipped over that. So that's rise 1, run 1, 2. Rise 1, run 1, 2. Rise 1, run 1, 2. And I can go backwards. Rise -1, run -2, because a negative over a negative is a positive. And so therefore, I know that the rise over run is 1 over 2. And again, as with all fractions, although these aren't technically fractions, they're slope, they act and look like fractions, and they can be put in their simplest form. The last example here is when you just know 2 points. Now, I could have done the same thing here because I knew 2 points, and we could practice that there as well, but we'll practice down here, and then we'll go and try that one as well. So on this one, you're just given 2 points. Well, we know that this is x, and this is x, and this is y, and this is y. And then you just have to pick, do you want this to be 0.1, or do you want this to be 0.1? Well, since I'm reading left to right, I'll go ahead and call this 1, and I'll call these 2. And it honestly won't matter which way you do this. You'll still wind up with the same answer. And so it says I take y2, that's over here, which is a 6, this y2 right here. Y2 is 6. So I put 6 minus y1 here. Y1 is a 4. And then on the bottom, x2, that's this one here. That's x2. And we'll put 3 minus x1, that's right here, 2. So 6 minus 4 is 2. 3 minus 2 is 1. The slope would therefore be 2, or 2 over 1, either way. And again, that's the slope, and we call this m slope. Now, if you would have done it the other way around, and you would have turned it around and did the labels differently, you still would be finding the change in the y's over the change in the x. So here we would do 4 minus 6 if we went this direction, minus over 2 minus 3. And if you notice, this would be a -2 over a -1, and I would still get a +2 over 1 or 2. And so you get the same answer regardless. You just have to be consistent with which direction you decide to go. So y2 minus y1 over x2 minus x1. I'll do one more example up here just so you can kind of see the difference between the graph. And again, on the graph, it's easy because you just count rise. How many places do I rise? What do I run? So rise 1, run 2. Rise 1, run 2. Rise 1, run 2. And it runs at the same constant rate of change no matter where I'm at. But if you pick any 2 arbitrary points, it doesn't matter which one. If I pick -2, -1, that's this point here. And I pick the other point up here, which is at 2, 1. This would be my x1, y1, x2, y2. And we can practice this skill one more time. And so I'm going to subtract the y's first. So it's the change in y over the change in x. And the more you write this, the better you're going to be at it. Change in y's, y2, and remember it's y2 first minus y1. And again, if you do y1 minus y2, just make sure you stay consistent. So y2 is 1, y1 is -1 over 2 minus a -2. And I'm putting it in parentheses because I need to keep, change, keep, change. And 1 plus 1 is 2, and 2 plus 2 is 4. And I can reduce this down to a half fraction, which is the rise of a run that I got. And so this is basically what we're going to be working with is slope. And remember, it's a fraction of rise to run, or change in y over change in x. I want you to use these notes because every single one of these examples is something that's going to help you. If there's a table, you're looking for the pattern. And again, you want to do y and then stick it over the x. So make sure you're checking the patterns on the y, putting it over the patterns in the x, or the change in x. And that concludes our notes. Please make sure that you are gluing this in sideways. Excuse me.